intelligent appliances. These are nothing but smart appliances with the help of which we can schedule the time of operation of different appliances based on their preferences, and we can also operate them at the off-peak hours to have the less cost. If you operate all the appliances at the peak hour, then cost of generation will be more, which will reflect in our bill. Okay, so if we operate them in the off-peak load, if unnecessary loads at the off-peak load, then the cost of generation will be less. Next slide. Then we have smart meters. Next one, it is smart meters. The smart meters, they provide two-way communication between the power provider and the end user. And this type of metering, it is called as advanced metering infrastructure. This enable the automatic billing, and it also do the data collection, and with the help of which we can detect the failure, and we also we can perform the repairs, and we can act in a faster manner, so that the self-healing can be achieved. Here we can measure the energy consumption every day or even in the hourly basis. The two-way communication can be done through either wired manner or through the wireless manner, like cellular communication or any other Wi-Fi or any other wireless networks. Next slide. Next slide, please. So this slide, it shows the difference between the analog meters and the smart meters. The monthly reading in the analog meters, we have the reading of the meter that is occurring in the monthly basis, but in smart meters we can have the reading on the hourly basis. Then we have the reading which is taking place manually in analog meters, but in smart meters we can have the reading even in the remote place, and it can be done automatically. Then in the analog meters we do not have any reliability, but here it is reliability of the system, it is being monitored. Then in analog meters it is one-way communication, but in smart meters it is two-way communication. Next slide. See, next it is a smart substation. As we have seen before, we are using many distributed generation that are being taking place at various places. This requires the introduction of electronic converters, so that it will lead to a power quality problem. Okay, then we have to go for a smart substation in order to take care of this power quality issues. And these smart substations, it is going to have many components like transformers, switches, capacitor banks, circuit breakers, and network protected relays, and several other components. Next slide. Next slide, please. This slide, it talks about the functions of the smart substation. The first thing is it is going to monitor and control the critical and non-critical data such as power factor, transformer status, circuit breaker, and security. Then we have reliable energy delivery. It transforms the voltage at several times, and we also have the electricity, which can be split into different parts, and it can be split into many directions. It can get the information about the power, voltage, and it also influences the power and voltage in a proper manner, and it also takes care of the power quality issues such as harmonics, voltage dips, and flickers. It also provides the sustainable power. Batteries and substations, smart substations. We can incorporate the batteries in the smart substation. If incorporation of batteries, it provides the power backup during the power failure. They also supply the power for switchgear, which help to isolate and clear the faults. And adapting the batteries in substation allows the better integration of digital and communication technology. Then superconducting cables. This type of cables, they provide 2 to 5 times more than the power than the conventional cable of same size. It can withstand high temperature, and it can also handle the worst environmental condition. It also has low loss, and so that it can be used for long distance. and it also provides automatic monitoring, analysis, and it also detects the faults. Example for such cable is the yttrium barium copper oxide, which is going to have a melting point which is greater than the 1000 degrees Celsius. So this type of cable can be used for used at the higher temperatures. Next slide. Next slide, please. Next one is the integrated communications. This is the most required part of the smart grid, and this part it should be very fast, and it should act in the fastest way to meet the real time. Then the many technologies like PLC, wireless networks, SCADA, and broadband power line, they are used in the integrated communication. Next slide. Then while choosing the integrated communication, we have to check whether how easy it is available for our use. The following points it should be considered for choosing the integrated communication. We have to check how easily it is available for use. Then the next one is latency. It is nothing but the propagation latency. It is nothing but the time taken to transport the information from the sender to receiver. Then we have to check for the standards. There are many standards that are available to exchange the digital messages, like syntax, semantics, and synchronization of all the digital communication. And the data carrying, the next one is data carrying capacity, which is expressed in bit per second. It states the upper limit of the bit rate with a negligible error. Then we also need to take care of security. The security should be ensured. This can be done using the secure socket layer protocol, which is a cryptographic protocol that provides the security for the communication. The next one is we have to check whether proper network coverage is there. Then this slide is about the phasor measurement unit. It is nothing but the unit which measures the magnitude and phasor of electrical quantity. For synchronization, this type of measurement, it is called as a synchrophasor. And with the help of this, we can capture the samples and we can reconstruct the phasor quantity. Then the synchronization, it is done by the GPS, which allows the real-time measurement of the multiple remote points. Next slide. Next slide, please. Then these are all the challenges of the smart grid. We have to ensure whether the communication, big data, cyber security, they're all reliable and fast. And we have to check whether the wide area monitoring system with energy management, SCADA distribution management system, and and they can be implemented and integrated. And we have to check whether suitable converter topology and the controls for renewable energy integration is available. And we have to also check for the optimal site for the smart grid. And we have to check for the sizing and control of energy storage systems. And we also need to consider the storage mechanisms due to the intermittent nature of renewable energy. We have to implement adaptive protection for active distribution networks and microgrid. And since the customers, they are playing a major role, they need to accept the renewable energy source development, and they also accept the demand side participation.